Good morning, guys. Okay, I'm going to do these last two examples. Number four. So it says given x squared plus y squared equals 3, find y double prime in terms of y. So notice this in terms of y. That's what's going to be the tricky part. That means that it's going to be y double prime equals an expression that does not have a dy dx in it. It has to have only x and y. When it says in terms of y, since y is in terms of x, having an x in there would be okay. But we can't have a y double, I mean a y prime. So I'll show you what that looks like. So first, just like with any derivatives, we can't find y double prime without finding y prime. So we differentiate first. 2x plus, make sure you can do this part. Remember, it's a chain rule. 2y dy dx equals 0. Now, we can go one of two ways at this point. We can go ahead and differentiate just as it is, or we can solve for dy dx and then differentiate. I'm going to, maybe I'll just show you both ways, and because I can erase. So I'm going to show you, let's write down the second way. I'm going to show you if I were to just take the second derivative, and then I'm going to do it where I solve. That's what I'm going to work with, I've decided. So if I just take the derivative again, we have 2 plus, now notice, this ends up, if I were to write this out, remember this is like this. We have a function times a function. So this is going to have to be a product rule. Maybe okay. So we have 2 dy dx times dy dx. So 2 dy dx squared plus 2y second derivative d2y over dx squared. I never know how to say that one. Equals 0. And now we would solve for that second derivative. So getting that second derivative by itself, getting this term by itself means I'll move these two terms over and then divide by this term. So d2 second derivative would be negative 2 minus 2 dy dx squared over 2y. That would be the second derivative. It couldn't be our final answer if we did it this way, but this could be one way to get the second derivative. I'm going to go back though and do it the other way because I think it makes for a nicer derivative to have to find. And since we're solving for y double prime anyways, it'll be done. So I solve for dy dx here, which would mean I move this one over and divide by this one. So dy dx is equal to, if I do negative 2x divided by 2y, notice those 2's cancel. So we have negative x over y. That's the derivative of a circle. It's kind of a good thing just to memorize that negative x over y. Um, so now we need the second derivative. Hopefully, again, you notice we have a function. F of x is considered a function. I guess I shouldn't call that f of x though, huh? That could be like g of x because y is f of x. So we have a chain rule. I mean, a quotient rule. So g prime f minus g f prime all over f squared. Which is weird because g is the top function in this one, but we take the derivative of the top first. So there you have it. We have negative y minus x dy dx all over y squared. Oh, this would be plus because of that negative with the subtraction. But something looked wrong. Okay, now that is the second derivative. We differentiate both sides, right? We're looking for that second derivative. So now we have to isolate the second, or now we don't have to isolate. Now it's done. That's it. Except, right there. We can't leave that. So I boxed it, but I have to undo that box. That's why I like having this, doing it on here. Right now, we have this dy dx in the problem. We can't have that. So we know what dy dx equals. That has to be plugged in for it. So we have negative y plus x times negative x over y squared. So we could leave it right there because we've technically accomplished what we needed to. Um, yeah, sorry. We've technically accomplished what we need to. We don't have to simplify, so we could stop right there. If you wanted to go look at the answer we got the other way, they'll equal eventually, but they don't look the same right now. It would just take some work to make them look the same. But there you have it. If you're told this in terms of y, just make sure you do this back substitution that we did right here to get everything in terms of x and y. Last one. So now we have a trig function. Remember, y is, sorry. I thought I was gonna sneeze. Oh, okay. So if we start on the left, we differentiate both sides. The derivative of cotangent is, hopefully you got it, negative cosecant squared y times the derivative of the baby, dy dx, equals 1 minus dy dx. So we got to get our dy dx's onto the same side. I think I'll move this one over. So I have dy dx minus cosecant squared y dy dx equals 1. We factor out that dy dx. 1 minus cosecant squared y equals 1. So dy dx equals 1 over 1 minus cosecant squared y. Nothing really revolutionary on that one. Just as usual, need to do a trig function because we all know how much you all love trig. Okay, watch those videos. Make sure they make sense, and then do number 1 on the worksheet. You guys have a good day.